pretty sure that this is Yellowstone ash that I picked up right around here. That's over there. This probably came from over there. And the reason why I know, or at least I think it's Yellowstone, is because we don't see any mica in it. There's no little black peppery pieces in it. Now, if there was black pepper-like stuff in it, that would mean there would be mica, and that would have come from the North Cascades, a volcano from there. Okay, here we are at White Bluffs, Washington, and then behind or in front of me here is the Columbia River. And I hope that you will enjoy this presentation that I'm about ready to bring, and this is about geological evidences here at the White Bluffs area, just outside of Tri-Cities, Washington, that will give evidence of a universal flood, a worldwide flood. Now, of course, if you're an evolutionist, you're probably going to want to shut this off because, well, you know, this kind of goes against your philosophy when we start bringing out the science in a universal flood. So anyway, those of you who have an open mind for the truth, I hope that you will stay tuned and you will watch this whole thing through so that you can hear the other side of the story that is not taught in the secular colleges, that's being censored out of the government schools. And so I hope that you will enjoy this and that you will learn something from it and you will be inspired by it. This is the Ringold Formation. We find mammoth bones, camel bones, sloth, rhinoceros, saber-toothed tigers, all that kind of cool stuff. Now, this is where you're going to find fossils. Leaf fossils, fish fossils, any kind of an animal fossil. Now look at those layers. Look how thin they are. They're perfectly stratified, each one of them. And there's no erosion marks between them at all. And this is a giant mud flow, and like I said, who knows how far this mud flow came from, how far it came from, how fast it was going. It had to be going extremely fast. And it had to be coming from a long ways away. There's no doubt about it. We even find giant ash layers in these mud flows. And a lot of animal fossils and leaf and fish fossils. I mean, this is just a wonder. Well, here we are at White Bluffs, Washington, and you can see way down there is the Hanford Nuclear Reservation. And as we go over here, as we pan over here, you can see the Rattlesnake Mountain and, of course, the Columbia River. And right here, right in front of the Columbia River, we have something really interesting here. Now, folks, let's think with the geological side of your brain. Just because we have a river right here, And just because we have what looks like, and they are rounded rocks. We have rounded rocks right up there. We have mud on top of that thin layer of rounded rocks. And then we have a huge layer of mud, or what was mud, below those so-called river rocks. But you'll notice it's a very thin layer. Now, conventional or secular geology will tell us that those rounded rocks, they were laid down by a river. I really doubt that. That is part of a giant, massive mud flow. And when you have massive, I just don't have enough faith to believe that those rounded rocks were laid down by a river, especially when you notice how thin that layer of rounded rocks is. You know, just because rocks were laid down, or just because rocks are rounded, does not mean that they were laid down by a river. I believe most confidently that those rocks were laid down in a mud flow, because obviously those layer of rocks are in a mud flow right now. I mean, the dirt above those rocks and the dirt below those rocks are now hardened. So at one time, this was a giant, massive mud flow, and you'll notice it goes all the way down this road. It goes around that corner, and what you're seeing here is just a small fraction, just a fraction of how giant this mud flow was. You see, this is the leftover. This is what has been eroded away. So this mud flow went clear across the river before this river was even here. And this mud flow covered way out there. And so this is another proof, this is another evidence to show that just because of what you see right now does not mean that it was also happening in the past. This really hurts this lame idea called uniformitarianism, that the present is the key to the past. The present is not the key to the past. Because things obviously were different a long time ago, thousands of years ago. Hence, probably the universal flood, the deluge as talked about in Genesis chapter 7. And this here is a strong evidence of a huge flood. And those so-called river rocks are part of a giant mud flow. They were not laid down by a river just because you have this river called the Columbia River here behind us. That does not mean that those rocks were laid down by this river. That does not prove anything. So this is awe-inspiring when you think properly from the geological side of your brain. Okay, now this is amazing what we're looking at right here. We're seeing a gray piece of material, and I am almost certain that that is volcanic ash that is between two mud layers, and look at the angle of it. So if that's volcanic ash, which I am certain that it is, then where did that come from? But that's all part of a mud flow. That's all part of a mud flow. You see, this is another piece of evidence once again, because we don't see any erosion marks. There's no erosion marks between these different layers, which is strong evidence to support, once again, that these layers were laid down quickly over a short period of time, not over immense periods of time like what they will teach you in the government-controlled government schools. And so, if that is ash, then where's the volcano? It seems like everywhere you go, whenever you look at mud flows, there's always going to be volcanic ash in it. And what does the Bible say about the fountains of the great deep? Well, it was the fountains of the great deep that flooded the whole earth. And the fountains of the great deep were volcanic. And of course, volcanoes, they produce ash. And what else comes out of anything that is volcanic? Lots of water. Lots of water. And so, once again, this is quite awe-inspiring what we're seeing right here. And this is all part of the same mud flow that you saw those so-called river rocks. And by the way, you might be asking, well then how did those rocks get rounded? well, you don't know how powerful that mud flow was, and you don't know how powerful or how long the distance that mud flow came to round those rocks, to make people think that those are river rocks. Those rocks got rounded because the mud flow was so terrifying, and it flowed for a long ways. And I would venture to say that they came from northern Idaho into from Montana to here. And that would have been before the Missoula flood. Okay, here's more of the volcanic ash layer between the two mud flows. Now there's color in that volcanic ash. There's gray, there's white, and if the sun was out better, we would see more color, I'm sure. Now when you look at these layers, what does this remind you of? Well, this kind of reminds me of places I've been in Utah, Arizona, Montana, the Montana Badlands, in the Hell Creek Formation, where they're finding lots of dinosaur bones, T-Rexes and stuff like that. And by the way, this is part of the Ringold Formation. And what do they find in the Ringold Formation? All kinds of animals that you don't see around here today, like camels, saber-toothed tigers, mammoths, I believe giraffe bones, rhinoceros fossils, leaf fossils, fish fossils, all of it together in this one area. But it doesn't just end here. It's all over the world. And this is more evidence, if you just open up your mind, it's more evidence, once again, that the whole world was of one climate. Now, I believe there's a lot of evolutionists that will agree to that at one time the world was of one climate. And we, real scientists, that believe that God created this earth and agree with science, that science does point us towards the universal flood. We believe that it was definitely of one climate because the evidence shows that it was. I mean, if you've got rhinoceros fossils and camel fossils, saber-toothed tiger fossils, mammoth fossils, and we're all in the same area, same layer almost, well, you could say then that the earth was of one climate, because we don't just find them here, they're in other places of the world, not just here. And so this is really spectacular. Whether you know it or not, you should be in awe about right now. This should amaze you, this should interest you. This is not a personality deal. You know, this is the planet we live on, and the planet was affected by a universal flood. I'm going to say about 4,500, 5,000 years ago. And we are seeing the evidence of that right here. Okay, here we are once again, White Bluffs, near the Columbia River. And what you're looking at is a giant mud flow. Now you have to think about this a little bit. Don't let the landscape fool you. What you're seeing here is the top of the mud flow. And that mud flow continued on. It went across where the river is today, but the river wasn't here at that time. And it flowed out across this landscape, and it covered everything here. And then it was sometime later, the Missoula flood came through here as a result of the Ice Age. And that Missoula flood, it gouged all this out, carved all this out, and it left this remnant of this mud flow. Now you're going to think about this, you're just seeing the top of the mud flow. That mud flow went way deeper than what you're seeing here. Like I said, this is just the top of the mud flow. I'm emphasizing that because I want you to be in awe about how huge this flow had to be, and considering that it came from hundreds of miles away, most likely from Montana, all the way to here. Now, how do we know that it came from Montana? because in a lot of these flows, we're seeing quartzite. And I say this tongue-in-cheek because we don't grow quartzite around here. Quartzite came from the Rocky Mountains. And so we can trace this quartzite back to northern Idaho and Montana. That's where it came from. It's kind of like a fingerprint. So we know where these mud flows came from because they have quartzite in them. And I'll try to find some here, put some in the video so you can see it. And this is not the only place where you see this mud flow. This mud flow goes for, I'm going to say 30-40 miles at least. But that's what we see of it. Now, like I said, a lot of it has been eroded away by the Missoula flood. And I can't overemphasize that enough. Okay, here we are once again, looking over the Columbia River. And over there in the distance, you're looking at the Saddle Mountains. And Saddle Mountains is full of petrified wood. It's all over. You find huge logs, and according to some experts, they claim that we haven't even touched the tip of it yet. That there are thousands and thousands of petrified logs under the ground. And then as we swing over this way, we immediately are met with all of these really cool sedimentary layers created by a mud flow that we've been talking about this whole time in this video. They are becoming more well defined as we go up in elevation. And this is the same layer that we find all of those cool animal fossils. Now, I don't believe that they found like the saber-toothed tiger right here, and the camel and the rhinoceros and the mammoths and all of that. Actually, you see, once again, this mud flow, it actually goes over there into the Saddle Mountains. And that is where somebody several years ago found a lot of those fossils, is in those mountains. Actually, I think it's on the other side of those mountains. Now, don't quote me on it because I'm just trying to figure it out. The guy that did this, he's pretty secretive about it, which I don't blame him. And I'm just theorizing that he found all those fossils in that mountain range on the other side of the mountain range, where you see similar mud flows like this right here. In fact, in that mountain range, we actually find very deep Yellowstone ash. That's right, you heard me say it. Yellowstone ash from Yellowstone that blew up. And I'm going to say that that would have been pretty much post-flood when Yellowstone blew up at that time. It's blowing up twice. And anyway, there's a lot of fascinating geology around here when you finally get to really know what's happened in the past, when you know how to read the layers and know how to look for fossils, know what you're looking at. Another thing that I want to impress upon you is that we are overlooking a very flat place, very flat plains, as you can see, and then we have mountains that circle this plain. Now, this is where the Missoula flood came shooting through here through a water gap, through what's called Sentinel Gap. And the Sentinel Gap, it split the Saddle Mountains in that direction that you're looking over there. Hopefully you can see Mount Rainier off in the distance, and you see the different nuclear reactors. They're shut down now, of course, but there's a lot of history and geological history out here. And it's amazing when you think about it, You think about this huge wall of water rushing this way and carving all of this out. And then later on, the Columbia River started to flow through here. Now, I don't know what this is for sure. Okay, for reference, see where we're at. Okay, see where we're at. Now, these holes are perfectly round, and they go way back. I forgot my flashlight, so I can't see how far back it goes, but it goes back quite a ways. Now, when I look at this, this reminds me of looking at petrified log cavities in basalt. But this here is in sedimentary layers. Now, can a human being or an animal dig a hole so perfectly round? I doubt that. These holes look as though that at one time in the past, these mud layers, they covered over logs. And look, they're all in a perfect line. They're in a perfect line, and they're in a certain sedimentary layer, which is amazing to see. And so this would lead me to believe the only option that I know of is that at one time these housed logs. And I'm not saying that they were petrified. They probably weren't, because they're gone. They're eroded out. Because if a log doesn't petrify and it just stays wood, it is going to deteriorate, especially in mud. And so this is really amazing to look at. This is like totally amazing. I mean, this should put you in awe. In case if you don't know it, this is amazing and you should be amazed. Okay. Okay, I'm just walking along here and I am just blown away again. I can't believe what I'm seeing. Now, people, those of you who are watching this video, think with the geological side of your brain. And for reference, you'll notice, okay, we are along these sedimentary mud layers that were, well, they were mud and now they're hard as a rock. And you're going to notice something here that's a little strange. Because if you follow these sedimentary layers, you follow them along, they are perfectly horizontal, and then all of a sudden we come to like a big glob of mud that is running between these layers. So you got these layers here, okay, so you got these layers, you come to the glob of mud, and then the layers continue on over here. So these layers match up with these layers over here. But you got this glob of mud right here. Now, in case if you don't know it, once again, this is something to be in awe inspired over. This is amazing, this is cool. And you should be going ooh and ah over this, because people, what this is a giant clastic dike. This is something similar that you see in Kodachrome Basin in Utah. Except in Kodachrome Basin, you actually see the dike is sticking up out of the ground and everything has been eroded from around it. This dike here is what proves that all these layers were laid down quickly, and they were all laid down at the same time, really, basically. Yes, they were. They were all laid down at the same time, and they had to be mud all at the same time in order for this clastic dike to be here. So here's what happened. So you have these floodwaters, and they're pushing down on this hillside. Now you have to remember something. This hillside is a remnant, it's a leftover. Okay, at one time this hillside was not here, but all this mud was here. Okay, now like I've been saying previously in this video, this is a remnant, this is a leftover. And I guarantee you that this mud that you're seeing, of course it's hard as a rock now, it's all dried up. But at one time this was much deeper, it was much higher in elevation. Okay, so you have all this water, and it's pushing down all these sedimentary layers. But there's a crack that forms, or there's a weak spot that forms right here. And so as the water is pushing down, there's mud underneath, and that mud gets squeezed up. It gets squeezed up through these sedimentary layers. It would be like as if you blew up a balloon, you know, one of those long balloons that you blow up and you put the tail of it on a dog, you know, it's a real long, it's like a long tail. And you squeeze on both sides of the balloon, and what happens? Well, the center part of the balloon, it squeezes up. Okay, so this is also another good example of it. It would be like toothpaste. You squeeze the middle part of the toothpaste container, and toothpaste squeezes up through the mouth of the toothpaste tube. Okay, and that is what's happened here. Now, the only way that could have happened is if all these sedimentary layers were mud at one time. They had to be soft, they had to be all laid down at the same time, not over millions of years. Okay, so there's not like immense periods of time between each one of these layers, and these layers were not laid down over a long period of time, and this clastic dike right here proves that. Now, this is kind of exciting. I found what looks like ripple marks here in the mud. And of course, this is not mud anymore. This kind of, my finger gives frame of reference. Okay, so it's a small piece, but that definitely looks like ripple marks to me there in what used to be mud. So that is a good find for today. Now you think about it, a ripple mark like this is very fragile. So the ripple marks were created, and then it had to be covered over quickly to preserve those ripple marks. And here is the other piece to prove it, right here. So this piece gets covered over, and then more mud comes over the top and protects those ripple marks. Just like that. Okay, now, when you go to the ocean, go to the beach, you'll see ripple marks in the sand, but those ripple marks, they are not preserved. In just a few minutes, they'll be destroyed. So these ripple marks had to be made quickly, and they had to solidify quickly. And then they were buried quickly to preserve them. And then, thousands of years later, somebody comes along like myself, digs around, and voila, you find them perfectly preserved. Now, some people, they may disagree with this. They would say, well, that's not a ripple mark. Well, I can't prove it, but it sure looks like it. And it looks like a lot of ripple marks that I have seen in the Southwest. Ripple marks that I have seen off of Highway 97 between Leavenworth and Cle Elum. And I don't know what else you would call those, but one thing we do know, that when we find preserved or fossilized ripple marks, we know that they were made catastrophically, and we know that things were different in the past. They're not like now. So different in the past that some agent had to be in that mud to solidify them quickly, and then have another mud flow to come along and then preserve that. Otherwise, you know, if this ripple mark is left out in the elements, in the wind and the rain, it's going to be destroyed real quick. You know that. That's common sense. And so another mud wave had to come along and cover this up. And so that's a good point. Okay, now if the rocks could talk. Now remember, I was telling you before that we know that these mud flows had to come from, at least from Montana, northern Idaho. So here we're finding granite, rounded rock. That of course the evolutionists, they will call that a river rock. I would not call that a river rock. That is a mud, that comes from a mudslide. That is from catastrophism. And we go right over here, and lo and behold, here is quartzite. Now quartzite, that's kind of the fingerprint right there. That tells us that this mud flow, see all these rocks that they call river rocks are all jumbled together. And of course we don't grow quartzite around here. And here's some more granite right here. Granite or granodiorite, about the same difference. And of course we find lots of these rounded rocks that some people, they will call it river rock, but it's not river rock. This is a giant mudslide that came from a long ways away, and through all that abrasion, through all that erosion, these rocks were rounded in that giant mudslide. And that mudslide could have been moving 60 miles an hour up to 100 miles an hour. And so what we're looking at here is a whole lot of mud. Man, that is just one big glob of mud. I mean, that's just amazing to look at. And then, of course, in there you see just a small lens of what they call river rock, which, of course, is not river rock at all. It is a mud flow. Okay, well, I hope that you have enjoyed this presentation about the geologic evidences that support Noah's flood here in the White Bluffs area. And of course, I know that if you're an evolutionist, you will not have enjoyed this, probably not one bit. You probably will have hated this video. You probably want to stomp on my camera, and you probably just want to shut me up because you're so filled with love. On the other hand, if this is really bothering you, all of this scientific evidence, and it's just driving you up the wall, then you have to ask yourself another question. Is it really the scientific evidence? Or is there something else deep down inside of you that's just really bothering you, that causes you to become so inflamed with anger when you hear about the scientific evidence that supports a universal worldwide flood that is spoken about in Genesis?